Networking. Intro to networking. It's Wednesday, first week, day 2. Cyber defense. Need to think about it. We're going to meet Monday and or Wednesdays after class, or Tuesday, Thursdays after class. There is a possibility of a voting project, creating material to help people understand voting. If you are interested in helping with that, it would be doing some animation work and creating some training videos. So if you have an interest, let me know. Course, curriculum, items, focus, and time spent on it. We talked about how important that is. Then the first chapter has just a bunch of terms and it's talking about networks today and what we have in networks. We got started on packet tracer, make sure we know how to do that, and we'll have labs next week. And yeah, next week, chapter 2. Okay. You know, we don't have class Monday, so by Wednesday you should have gone through chapter 2. That's really important to stay on track. And what I say is set aside some time so you're not interrupted when you're working on the curriculum in order to do the best job. And probably in the long run, save time. You could probably get done faster going through the material and focusing on it than you would trying to do it along with other things. You really can't multitask well. Okay, so we have LANs. We have here, we're using NIAC as an example. It's great to use an example we're right here working with. Logged into a web server here. We have a firewall. And we have PCs here in the lab. This is a logical topology, and we started making a little bit of a physical topology. We started talking about where these things are. And Wednesday, we'll take a little time and we can walk around and look at these, review where they're at, or talk about where they actually are. So we have, coming into a network, connecting to a network, we have things like, I don't have it here, but we could also have printers. You know, could be a printer connected. So we have hosts that connect into the network. In some way we access the network. Okay? Now, there's a little more specific term. If your host is communicating with a server, like here we have a host, and it went through and it went to this web server and came back, then we have a client server scenario, which is extremely popular. For example, I'll use another color. These servers right here, when you log into a computer here, it literally goes over and looks at those servers and then comes back. Now, I'll make this a little more of a physical diagram. Those servers are in MH216 in the back of the room. More on that later. And then we can have our communications through the firewall out into the internet. And people in the internet, if they come in to our network, they can get to our server, but you'll notice the firewall won't let them into our internal network. This is sometimes referred to as, often a DMZ. You let people in order to access your servers. And of course the internet, people have to do that all over the place. Okay? Old networks years ago, in fact I remember when Newman was first wired, they had Cat3 cable. You'll learn a little more about these different cables later on. They had Cat3 cable going to a classroom, then they had a Cat5 cable for data, and then they had a regular cable, coaxial cable, go in, and that was for the TVs. They had TVs in the classroom, and they had one of them fancy things, VCR hook that could distribute the TV to all the classrooms. They had a computer in the classroom, and they had a phone in the classroom. These networks now have converging networks to where we can use one cable for everything. Well, we could use a cable, it could be fiber, or it could be in the air, but it could be a converged network that manages both voice, data, can handle, streaming of data, TV, so it can handle video, okay, all through the same communications network. So here's a little bigger view of what we worked on. So we talked about, internet, there's two different ways people think of the term internet. Technologically, the internetwork, in which it connects all these other networks together. So when you say, well, I went out to the internet and I found this, X, Y, and Z in the internet, you really didn't find it in the internet, you found it here. But the world today, in the bigger picture, they think the internet is all of this. It's kind of like Google. When you hear Google, you either think of the company or the search. But the word Google is really a really big number. Like you have a million, a billion, a trillion, and eventually you have a Google. Or tissue, Kleenex. Sometimes people use the word Kleenex. They really don't want the product Kleenex. They want tissue. The word internet's kind of getting that way. So, we talked about how we measure things going through the internet. We were talking about communications and how you pay for it. You get access and your usage. You can pay by gigabytes, how much actual quantity you moved, or you can pay for by the speed that it moves, bits per second, or typically some combination. We talked about how do you hook to the internet. Well, we have fiber to the house. That might be, it depends on the location, but that could actually be, we'll learn later on, what we would call long haul or WAN Ethernet. We have DSL, digital subscriber lines, and there's a couple different types of DSL going through the phone lines. Could be cable, like Mediacom, have cable running to your business or your house or whatever. If you still have the old phone lines, you can use dial-up and modems. That actually comes up later on. It's pretty slow, but there are some cases where dial-up would work. Send stuff through the air, satellites, towers, between towers, and cellular. We can connect the internet with your phones using the cellular towers and some type of data plan. We looked at communication to Dirksen.com, and we installed Packet Tracer. We installed and worked on Packet Tracer, and then we also, from the classroom, connected to the access router, which allowed us to connect to networking equipment. We'll be using that a lot on Wednesday. So if we look at the big picture, so we have a topology. Okay, some way of looking at our networks. And some things in the topology. If, for an example, you have two connections to the internet, you could build in some fault tolerance with your network. If one line goes down, you use the other way. One device goes down, fault tolerance. And you can build that right into your topology. Also in your topology, if we wanted to add, okay, so I gave the example, this is in a classroom, this is in a server room, we have this in another classroom. Well, if we wanted to add another classroom over here, it'd be pretty easy. We just connect it in and configure things pretty much the same except for this classroom. So that allows you to scale, grow or shrink, scalability. Okay? And the internet's the same way. You know, you never really know what's all connected to the internet because it's easy to add another faction into the internet. And all these connect in through some type of internet service provider. Now, some people, I will talk a little more about, there's other ways. You know, the internet we have a bunch of providers. They call them Tier 1. We talk more about that later on. Tier 1 providers. They're the backbone of the internet. Last slide. We talked about networks. Oh, here Walmart can use a service provider in order to connect. Let's say this is the Walmart Minneapolis, and this is the one down in Arkansas. And then the Walmart in Minneapolis, we can add new Walmarts in Minnesota maybe. So that's very scalable. It's very easy from here to add one here, and then they can communicate back to the main Walmart. We'll talk a little bit more about how companies do that. As they grow and get really big, they can pay some cloud service to help them organize their data at different locations, like Amazon Web Services, Azure. This is Microsoft, by the way. This is Amazon. IBM is IBM. Google has services. Apple. And this keeps going down to smaller ones. Light Edge in Altoon is a data center. And what do cloud computing do? They allowed you compute time, you can store stuff there, you can create a web access database, and there's lots of things you can do. It's kind of like a utility. Rather than you having to have all your computing equipment, you can just use theirs in order to make your company function and manage. Scalability. It's a big deal in the cloud computing. Also, they help you with fault tolerance and have different locations and so forth. Fault tolerance, I drew a little picture here where if this switch goes down, the traffic can go this way. You have multiple equipment. Quality of service. As information moves through a network, you want some information to have priority over other information, so you can design quality of service so that the traffic, like voice traffic, you don't want that interrupted, or video streaming, you don't want that interrupted. You can give those priority over other traffic, like somebody downloading a file from the internet, or somebody just browsing the internet. Okay. Security, the key words starting here: confidentiality, only who's supposed to see the information. Okay, that's that, encrypting information and so forth, only allowing, like at a hospital, okay, the nurses and the doctors have to see the information. It has to be made available, but they can't tell somebody I have AIDS, or I don't, but if somebody has a certain disease, you can't go out and tell the world. Okay, so that's confidentiality. Or the bank can't tell people how much money you have. Okay, or Apple iPhones, they encrypt the data on there, so if somebody steals your phone, they can't get at it, they can't see it. It's confidentiality. Integrity is the quality, the accuracy of the data. The data is accurate. So when you transfer money from one account to another, integrity would mean it didn't change. The account numbers didn't change. You can transfer $1,000 from your account to your friends, but somebody interrupts and takes the money and puts it in their account. Okay, now it's not the transfer, or they change the account number, and now it's not accurate. Or information stored about you. You wouldn't want people to have inaccurate information about you, like your medical records, or your job history, or your credit ratings. You don't want somebody going and change your credit ratings. That's pretty much the first chapter. There's a couple items about security we still need to clean up, and a little bit about the IT profession and jobs, and then we're going to go into configurations next week on Wednesday. That's it.